Hello friends, we will see now the subject manufacturing process in which we will study on sheet metal processes. Raw material, sheet of metal, rectangular, large raw material processing, rolling, anisotropic properties. Processes, shearing, punching, bending, deep drawing. Shearing, in which a large scissors action cutting the sheet along a straight line. This is shown in the figure, the shearing machine. Main use of shearing machine is to cut large sheet into smaller sizes for making plates. Punching. The cutting tools is a round or rectangular punch that goes through a hole or die of the same shape. In this figure shows the punching machine with die, in which we see crack, failure in shear, sheet, in punch of diameter, edge length or punch x shear length, x versus shear strength, place cut away slug. The die are on the both side of the punch. Clearance is given. Punching. Main uses cutting holes in sheets, cutting sheets to required shape. Punching. Typical punched parts are shown in the figure. Exercise how to determine optimal nesting. This is the exercise you should work on it. Nesting of parts. Bending. Body of Olympus E300 camera. Component with multiple bending operation. Component with punching, bending, drawing operation. Typical bending operations and shapes. Channel forming, joggle, hammering, flattening, two-stage, lock, seam, offset forming, straight flange, stretch flange, shrink flange, joggled flange, reverse flange. These are the examples of the flange. That is typical shapes bending operations. In the bending operations, sheet metal bending. Planning problems. What is the sequence in which we do the bending process or operations? That is given in the diagram, how we have to process the sheet metal bending. Avoid part tool, part to part to machine interference. Bending mechanics. Bending planning. What is the length of the blank we must use? This is shown in the figure. Bend allowances. It is given by the formula LB is equal to lambda in bracket R plus KT, where this section is under extension. Neutral axis. This section is in compression. R is the blend radius. Alpha is the angle of the bend. Length L is the bend length, and T is the sheet thickness. Therefore, we see in the bracket ideal case. In ideal case, K is equal to 0.5. Real cases, K is equal to 0.33. R is less than 2T. K is equal to 0.5 in bracket R is greater than 2T. Bending, cracking, anisotropic effects, Poisson's effect. Bending, plastic formation, deformation. Engineering strain is bending is equal to E is equal to 1 upon in bracket 1 plus 2R upon T bracket complete. Bending is given by this shallow failure cracking limits on corner radius, bend radius, etc. Effect of anisotropic shock. Poisson's effect is shown in figure. It is shown in figure cracks effect of an anisotropic shock. No cracks in figure A. There are cracks rolling direction in figure B. There are no cracks. Rolling direction is correct. Therefore, elongated inclusions straighteners. Exercise is given in this topic is how does anisotropic behavior affect planning. Now we will see bending spring back. How to handle spring back. It is given in the diagram. That is, A part is compensation. The metal is bent by larger angle. It is given by the formula RI R1 Y upon ET brackets cube multiplied by 4 times minus 3 times bracket in bracket R1 I Y upon ET bracket complete plus 1. B. Coining the bend. At end of bend cycle, tool exerts large force, dwells, etc. This is the process which is called as forming process. Thank you.